STAAD on the left-hand side and the RAM on the right-hand side. And all of the products under these two brands actually make up the Structural Enterprise Worksuite. Through this series of webinars, our intention is to cover all the topics or all the products which are contained inside a Structural Enterprise Worksuite. So in the same lines, today we are going to focus on RAM concept. So this completes the journey that we have started to cater to all the products that we wanted to cover in Structural Enterprise Worksuite. Now, RAM concept is a specialized software for slab design, but we'll look into it more in depth as we go through today's presentation. Please note that RAM concept is again a very vast software because it does FEM analysis on its own as well. So, but we are limited by the time and the agenda. So let's see that what we are going to cover today. So we'll look into that how we can input from structural system, RAM structural system and STAAD.Pro. So we can take input from STAAD.Pro to RAM concept for designing the FEM slabs. We'll look into briefly the procedure for designing flat slabs and post-tension flat slabs. We'll also run the tendon optimization routine and we'll understand that how it works. And also at the last, we'll perform load history analysis and vibration analysis. And of course, I hope you have so many questions. So let's begin with the introduction to RAM concept. So RAM concept is actually an FEM-based slab design software, which can design conventional reinforcement slabs as well as post-tension slabs. This also includes and applicable to two-way slabs, one-way slabs, beam and slab systems, band beams, waffle slabs, flat slabs, and also the mat foundations. So essentially, I would say whatever you consider as a flat plate, whether it is a mat foundation or elevated floor, that can be designed with RAM concept. Some of the user projects I wanted to show it to you that has been done with RAM concept, and these are some of the renowned projects like Shard at London Bridge Quarter, Marina Bay Sands, Singapore, K2 Business Park, Russia, then Trump International Hotel and Tower, Hawaii, US, and there's another one, Bun Blackfriars in London. So these are some of the iconic projects that has been done on RAM concept, and users like to use RAM concept for the high-rise buildings especially. And did you notice in the previous slide that we actually covered almost the entire world, including Russia, Singapore, US, and then other parts of the world, and that is because of the vast design codes that RAM concept covers. Apart from all the additions of ACI code, we have the Australian code, the BS code, our own IS 456-2000, along with the provisions of IS 1343 for post-tensioning, and Eurocode with annexures. So almost all annexures of Eurocode can be covered, and as well as the Canadian code. Now let's look at briefly the steps that we may need to do in RAM concept to design the flat slabs. So of course, we need to create the geometry, or we may need to import the geometry, first of all, to get started. Then the application of loads and load combinations. And there is a unique criteria which I like personally very well, is that you can associate load combinations with design rules, which means that you can dictate to the program that for these load conditions, check this particular criteria. And that's very well controlled by the program. The next is generating the design strips and then assigning the design parameters to these design strips. And of course, the last part is to review the design results for various design rules like service strength and code minimum, etc. So let's cover the modeling techniques. There is a complete integration, which I would say is a two-way integration with RAM structural system with RAM concept, which means that if you have attended the previous sessions on RAM structural system, you might know that RAM structural system is a 3D building analysis and design software. And from there, you can transfer the slabs directly to RAM concept. Once RAM concept does its analysis and design, the residual forces which remains at the corner of the columns can be sent back to the 3D model in RAM structural system for redistributing those forces into the 3D model. So that's how the complete integration exists between RAM structural system and RAM concept. We can import model from STAAD.Pro also, and in this presentation, I'm going to cover that part as well. We can also trace over a CAD background. So in case you have a 2D CAD drawing, you can directly import that into the program, and then on top of it, you can draw it. So it's just a matter of minutes before your structure gets ready. One important thing here, which I want to cover, is that most of the other softwares which does just the slab design, they are essentially a 2D program. But RAM concept, even though it is designing a slab in a particular file, it is actually a 3D program. That means it considers the walls and columns at the bottom and the top, and it performs a 3D FEM analysis on that particular model to get to the results. So it's very unique in that manner. And of course, the RAM concept is also BIM compliant, so you have the facility of ISM with it. And in case you are using any of the 3D modeling software like Open Building Designer or Revit or any other third party who are compatible with ISM, then of course you can directly import those models. So these are the ways through which we can get the model inside RAM concept. Now to get started, let's look at this structure. So here I have a high-rise building in RAM structural system, and I'm going to import one of the slab from this building into RAM concept. So this is one of the criteria which I mentioned through which we can model or probably import the geometry inside RAM concept. So let's look at this in action. Here's your RAM structural system model, which contains all the primary and essential geometry. We have done all the analysis steps which are needed. Then we'll click on RAM concept, which is on the left-hand side. And the dialog comes in, which asks you to select the slab which you want to send to RAM concept for further analysis and design. With the default parameters, I'm going to send that all the relevant geometry to RAM concept. And then the program starts. And I will go to the mesh input layer. Now in the mesh input layer, I can see all the geometry that was there in RAM structural system that actually came here. And then I can mesh this directly and can show you the 3D model of that particular slab. And as I said, though it is analyzing a slab only, but it is still a 3D FEM analysis program. So that's probably by this diagram, you will be able to understand that what's going on here, what we are going to analyze. And you will see that all the drop caps and the beams that we have in the middle slab are also completely imported from RAM structural system to RAM concept. Now, the next part is that we want to understand that we are using the relevant design code, which is in this case IS 456-2000. So I'll change that. And also, I will make sure that the load combinations are in accordance with the code that I selected. And here what I actually tried to tell you in the beginning is that program gives you ability through which you can combine or associate those load combinations with particular rules for which it should check. So that's very interesting. The next part in the workflow is to generate the design strips. And if you are new to RAM concept, then of course you might be wondering that why there are so many layers. So this is how actually the program is arranged. Every input that you are going to give is on a particular layer, which are bundled on top of each other to get to the final model. So the next one is generating the design strips. And of course, I think all of the structural engineer community agrees that in a slab design, it's the most important parameter, or I would say the concept that is there in slab design. So how RAM concept handles it, let's look at that in action as well. So what you see on your screen at this point of time, the mesh that the program generated before having any design strips, because the design strips will also dictate the lines or the points that needs to be included inside the mesh. That means also that once you generate those design strips, your mesh will be much, much finer than this, what you are seeing over here. So let's look at that in action again. Now I will navigate to the design strips layer. So let's go to design strips. And then I will navigate to latitude, design spans. And here you can see that I have generated some of the spans. And actually, these spans control that how the strip will be generated, whether it is going to be a code slab. Code slab means that 25%, there will be 25% of middle strip, then 50% column strip, then again a middle strip. And the column strip and middle strip properties are controlled by these design sections. Now, once you have drawn that, concept is way too smart. And I did the same thing with the longitude design spans. And then I just need to click a button here, which is generating the strips. And you can see that the middle strip and the column strip, that's what we have seen and what we have read in our textbooks has been generated. We might need to help the program a little bit at some locations, but you can see that strips are way beautiful, looks beautiful here, and that can make the design much more efficient if we have good strips. Now the next is, after generating all those strips, the next is just to calculate the reinforcement that has been required, or the other results like the deflections and the moments. So all the analysis and design steps will be performed in this step. Because we have already given the geometry, we have already given the loads, we have already given the design parameters. So here you can see that I've got some of the warnings regarding that reinforcement are too close to each other, which I may need to resolve before I finalize my design. But let's first of all look at the design status. So let's go to status plan. And here I can see that my middle slab is almost passed at almost all the locations. There are a few locations which might need my attention, but on the here, which is actually a flat slab, there are some sections which are failing. But the criteria which has been mentioned here is clause 40, which is the one-way criteria. And probably I will just increase the thickness of this flat slab portion and it will be okay. One of the interesting part in reviewing the results is that you can generate the result at any point in RAM concept. So once I click on any point, I can generate a report which will tell me that the final check of the strength design has been performed with these demands. And it will also show you that what is the minimum capacity, the minimum demand, the maximum demand, and the maximum capacity, which is available in the moment and the shear. So at any point you click, this report can be generated. Similarly, if we have performed the punching shear check, in this case, I've just performed punching shear check for the columns which are located in the flat slab portion. And once I click on any of the columns, the report will be generated. Now, the report says here very clearly that there are two sections found which are which needs investigation. And then the program goes under the section 1 and investigate it. And then again, the section 2. So here's the audit of section number 2, and then gives the status as OK. These are some of the numbers which you might be interested in, like the maximum absolute stress, allowable stress, and the unreinforced stress ratio. There's one more important graph here, which is the deflection graph, which we would like to review. So here you can see the maximum deflection is about 19 mm, which is almost okay. And there is portion here which is which probably may need some attention, but these are the deflections in the service case, so seems okay at this point of time. We can also review the reinforcement plans because we got some warnings, so we might want to look at those ones. And let's also look at the punching shear plans. So here you can see that all the columns for which we perform the punching shear are actually passed. Now, as I said, let's look at the reinforcement, and let's go through the detailed 3D view that the program has generated for us. So actually, the program can generate the 3D rebars for you, and fortunately, you can even export this to any of the program which is available for editing, or let's say modifying as per your standards. Here you can see a case where there is a drop cap, and the program actually gives a very good reinforcement. around that particular column. So, and there are some areas which I can see that actually needs attention because the bars are too closer to each other, that we may need to go and review the situation there. You can also get these kind of drawings, which are like top bar plans and the bottom bar plans, which you can of course export and improve upon for the delivery purpose. So that's how normally we perform. So in this scenario, which I presented here, we actually designed a beam slab system as well as a flat slab without post-tensioning at this point of time. And yeah, the program has given some warnings, but those are pretty easy to resolve as we go through. So let's go through one of the other important criteria here. We saw that how that reports has been generated at any point or locations. We saw some contour plans as well. So RAM concept is particularly I would say blessed with a very good output viewer. So just I think we are just adding a feather in that cap, that we have introduced scripting APIs for RAM concept. So if you have some knowledge of Python, then we have introduced some APIs in Python through which you can automate some of the stuff at this point of time, but we are working on introducing more and more APIs going forward. So that's actually just, as I said, we are just adding feathers in the cap of RAM concept. RAM concept is anyway much better in terms of reporting the results. Almost any calculation that RAM concept has performed, you can get the calculation in writing from the program. Now let's look at the design of post-tensioned flat slabs. And what you see here in the procedure is the only thing which is different is that we need to generate the latitude and the longitude tendons. Apart from that, all the steps are similar, like creating the geometry, applying the loads, and then associating load combos with design rules, and then generating the design strips. So all the other steps will remain same, but the only difference is that we, or an extra step is that we need to generate the tendon plans. Now for this exercise, we are taking a STAAD.Pro model. So here is an STAAD.Pro model on your screen, and we are going to import a slab from this STAAD.Pro model into RAM concept. So let's look at the procedure very closely. Again, a successful analysis is required before we can export the slab to RAM concept. So you can see that analysis output is available, which means I have performed the analysis. Then I'm going to click on Advanced Slab Design here. The dialog on the right-hand side asks me to create an envelope. So for all the load cases which are available inside this model, I'm going to make an envelope and say OK. Then I need to identify the slab which I want to send to RAM concept. And that for that case, let's go to the front view and select this portion. Please make sure that a geometry cursor is needed here, no plate cursor, no beam cursor. So this is what I've selected, beams as well as plates, and I can click on new slab and associating that with the envelope. So you see that slab 1 and slab 2 are generated, and then I can click on export the data to RAM concept, and that's something has been exported. Then I can click on open in RAM concept, and the program opens. Here it asks me that which design code that you want to go at. So I'll select ISO46 and gives me information that what has been imported. So here you can see that this particular elements has been imported directly from the STAAD.Pro model. And again, we can look at the 3D structure so that we know that all the elements have been imported perfectly or not. Again, as I said, the next steps will be much similar to what we have seen earlier. So I'm skipping those steps. So here you can see that the design strips are already been generated for the latitude as well as the longitude design spans. And these are covering all over the slab. Here also you can see that we have generated the longitude spans and also the punching shear check. So let me cover this here. So punching shear check, we give a search radius to the program and tell that how many sections that we want to inquire from the program. So let's say I'll say 4. And if in case requires the stud rails, that which stud rail I want to use. So that's what I'm selecting here in the punching shear check plans. Now the next step is to generate the latitude plans, latitude tendon plans, of course. Now in this one, in the latitude, I'm going to generate some bending tendons, and I'm going to have, let's say, considering the pre-compression, the minimum pre-compression limit, I'm going to consider, let's say, 14 strands here at these locations. And then I may need to increase at the middle of the slab. So I'm considering, let's say, 25 strands here. And these are just very rough estimates at the beginning. And again, same 25 strands for this pay as well. And now for here, I'll just change this to back to 14, let's say. And then let me generate the tendon profiles. Now, once we have decided upon the strands that we want to generate, the next task is to generate the drapes of it. That means where it will go up and where it will go down. Definitely, we want to cover that up. But Concept can do that in one click, just like that. So it has given you that bottom cover at the middle is 30 mm from the bottom, and the top cover is 30 mm from the top. Now what I'm doing here is at certain locations, I can see that these strands are not being crossed by these profile polylines. We call them profile polylines because these polylines actually decide that how will be the profile of the tendons. So it's important that they does cross with the tendons. Now let's go to the longitude plan. And here I will generate the distributed tendons. And for that, I may need to draw a rectangle here. Please know that I am using unbonded tendons of 12.7 mm. In this case, I'm using 1 strand per meter. And let's generate some of the quadrilaterals, and under which these spacing limits and the tendon limits will be applicable. So I'll generate 2 quadrilaterals here. And then for the inclined portion, I will give a banded tendon here, let's say considering 7 strands only. So let's generate this. And then again, the same procedure that I need to generate profile polylines, this time for the longitude direction. And let's generate those. And I think I made a mistake here, is that these should be oriented at 90 degrees. So here we go. this look correct. So now we have generated the latitude tendons as well as the longitude tendons and also the profile polylines. This actually completes the process of or the steps that we wanted to cover before we go ahead and analyze. So here you can see that these are the generated strands, and the digits which has been written here is in context with the from the bottom of the slab, that the elevation of these tendons. So you can see the drapes going around. And let me tell you that I've just given the hint of that where I need the tendons. These have been actually generated by the program. I have not drawn them manually. Now, if I go ahead and let's say generate the mesh once again, because it needs the mesh once again, because we have changed a lot of things. And here I can see some warnings. And let's say this time I wanted to tell you that how to resolve these kind of warnings. So I will ignore at this point of time, but I can see these warnings are there. And the warning is about that the radius is less than what is allowed. And here we can see that, yes, it actually is a problem here. So what we may help the program is we can help in the how the tendons will actually drape at this section. So I'm going to draw another profile polyline. From the top cover, I'm going to give an elevation of 125, and it is going to be a span profile polyline. And let me draw that here. And that should take care of this problem. Let me generate the tendons once again. And there are a couple more areas where I need to do this stuff. And I think now I'm get rid of the warnings. Cool. So once the warnings have been gone, let's look at the status plan. And I can see that most of the area is actually cleared. There are some areas where probably I'm failing in punching shear. And, yeah, these two columns is actually, and there is one more. So these are probably I'm failing in punching shear. I can also check that by going to the punching shear status plan to understand that how much is the the ratio. And here in the 3D view, you can see that what actually we have generated. So the red lines, which you can see here, is the tendons, and the yellow ones are actually the reinforcement. And here you can see some stud rails also. So this is how we can easily generate the tendons and their profiles, and then can analyze them and can get these beautiful 3D outputs from the program. Now, before we jump on to the next step, let's cover a few poll questions. So one of the question here is, do you work in building industry? And I'd say please record your answer here. There is another poll question for you. Which product are you using for superstructure concrete design? Is it the STAAD.Pro batch mode, the STAAD.Pro plus RCDC, or you are using Graham structural system? Or let's say in that case, if you're using any third-party programs. Please record your answer. It will actually help us give you a good content. Now let's say once again, let's look at that what we can do with tendon optimization. Now, what we have seen in the previous example is that we were actually failing in some of the criteria, but I didn't resolve that purposefully because I want program to help me there as well. Though I can spend some time and can resolve all those warnings and can give a very optimized design, but that will take time, as we all know. And with the tendons, there are actually almost, I would say, unlimited permutations and combinations that you can try, and those all designs actually pass. But the question is, which is the most economical design? So that is where I'm just considering here on this slide a very simple slab with just 3 spans, and there are 2 small cantilever portions. So here you can see that I can vary the tendon strengths, let's say from a maximum value. Okay, so from minimum value of 12 to maximum value of 30 with an increment of 1. And also I can even vary their drapes, which means I can vary the elevations of these tendons, which means that let's say I'll fix the elevation at the top of the column. That means this area here is fixed, the elevation here is fixed, but I want program to optimize me that how it will drape from here. That means that what will be the elevation at the middle of the span. So I can go, let's say, from minimum value of 1 inch to 4 inches in a typical slab with an increment of 0.5. Then again, I have small cantilever portions here. Then again, it will again add complexity to the problem. And again, there may be you want to explore the different slab thicknesses. And if I include all these permutations, these actually, as you can see on your screen, it actually blows your mind that there can be about 176 million possibilities of a single design, even with a simple slab like this. So there are, I would say in a typical design, there are unlimited combinations that you may try, but the question is again that which is the most economical design, and with the cost of tendons is so high that I understand that we all want to optimize it to the better, but because of the budget constraints and the time constraints, we probably explore 1 or 2 of the scenarios, but not all. So here programs actually comes in to help you. Now, this is one of the example what I was trying to tell is that for a simple problem like that, there can be multiple valid designs. So here you can see that in the valid design number 1, there is a higher PT. There's a lower PT in the first design, but the rebar cost and the stud rail cost is higher. While in the design number 2, the cost of PT is and the will be higher than the previous one, and the rebar cost and the stud rail cost is lower. So how we actually made our goal is not by just reducing the PT, but actually what we want to reduce is the total cost of the slab, or I would say there are certain parameters which we can vary, which are actually the cost of the PT, cost of rebar, and the cost of stud rails. Because of course the concrete cost and the labor cost is somewhat decided, but what we can vary and achieve a better design is by varying these three alternatives or parameters, I would say. So it depends whether on the cost of PT probably, that whether the design number 1 is most economical or design number 2 is most economical. So that was the goal that we have taken. And with that, I'll use the same slab that was not actually passing the design at certain points and throw it to the program and let it analyze as many as permutations and combinations it wants to go ahead with, and then give me the most economical design that's possible with my parameters included. Now, it's also important for me to let you know here is that because I'm saying that there are so many combinations that the program will try, it is not possible on a desktop application. So what I need to do is I need to send this to cloud. Yeah, that's true. So I need to send this to Bentley Cloud Services, and there, the same problem will be distributed among several systems, and it will be much faster for me to get the results. The effective part for you is that while it runs in the cloud, you can work on your model because it frees the model. So you can still work on a model or probably another model within the concept, with RAM concept or the software, or do any other work. And the cloud computing will do all the work for you. So yes, there is a bandwidth issue with all these combinations, which can only be done at this point of time in clouds. So let's look at the procedure and how we are going to prepare our model. So this is the same design that I performed in the previous exercise. I'm going to take that exercise further into the cloud, and we'll show you that how much is the difference between the cost that I calculated probably with this unfinished design, and then what program has given me with the finished design and with the most economical design. So let's look at the procedure for that. So I'm going to add some optimizers. So and before that, let me tell you that in this lab, I also considered the temperature loading. This has been a requirement from this Asian region that that temperature loading is must for a slab design program. So we have introduced it. So if I go to loading, and I will find temperature loading here. And if I show you that in this model, I considered about 10 degrees of difference. The top temperature is 30 degrees and the bottom is 20 degrees. So that variation I've considered here in this particular example. Now let's prepare our model for optimization. Now here I will optimize, of course, the tendons, and there is an optimization tab here. I will click on optimize, and I'll tell the minimum and the maximum ranges for the program to try. So let's say 10 to 30 looks like a good range. Actually, the minimum that is required, I'll try to multiply that by 3 or close to 3 for the maximum value, and that actually yields good results. So here it's the range between 20 to 40 for the middle base. And similarly, I'll give this, again, a range of 20 strands to 40 strands to the maximum. And similarly, this layer as well, I will give on 10 to 30 as the maximum ranges. Now, there can be you can do optimization for the top points if you like, but I would refrain using them. I'll just want to optimize the bottom points the lowermost point so that it gives me better and accurate results, or economical results actually. So I'm going to optimize only the bottom points, that is in the mid of the slab, mid of the span, but not at the column or support polylines. Similarly, I need to do the same thing in longitude plan. So same stuff, selecting the tendons, going to the optimization tab, and then saying that what is the minimum and the maximum criteria, and that will actually prepare my model. Once you have done that, you can click on Optimization Manager here and create a new scenario. In case your model is not located already on the cloud, it will ask you to locate it. And let's say I'll give a specific name, and with that, I'll send this to the clouds. The operation is in queue, and then it's running, and I'll just speed up the process a little bit. It takes a time because it is trying so many possible designs. So as you can see here, in here is that the red line here is actually where the design did not pass. From green line where it starts, actually the design started to pass, and here you can see that the model cost has been reduced tremendously by the program from where it actually started. So I'm stopping it here. You can let it complete as per your convenience, but I think I've optimized it enough, and I will stop it here. And that's the model cost I'm getting as the total cost, with of course no failures. So how program actually optimizes these three costs you can see over here is the PT cost, rebar cost, and the stud rail cost. And that was the optimized cost. Now what you can do here is you can load the best design and review the results. So I loaded the best design from here, and then I'm performing the analysis, and I can see that, okay, all the design has passed, and it is the most economical design, which is giving me the least cost possible. And that's actually probably what I need. So this actually takes away the pain of engineers that they have the time constraints and the budget constraints, because of which they cannot perform the optimization. We are not saying that you cannot perform, but we are saying that you will need time, which the program, of course, can you can utilize the program for. Here I'm displaying some of the deflection plans because optimization does not take care of the deflections. Please make sure of that. After optimization, you need to go back and check the service criteria such as deflections so that they are under the limit. There can be one question here from your side. I just anticipate and answer that all the combination that the program tried, you can download all those combinations. Just one, probably the best, or all. And you can study those and compare the different alternatives if one does not actually as per your expectations. But there are several scenarios that actually program has tried, and you may find the best design that the program has done. So that's how the program optimizes the things, which means the only input that I need to give to the program is that where will be my tendons, and what is the minimum and the maximum limit, and the program will optimize on its own. Now let's look at the load history deflections, and it is utmost necessary in post-tension slab. Of course, in the case where the optimization has been done by the program, it's probably more necessary than with probably the manual design, because we take care of the deflections ourselves, but the program did not actually understood that criteria. And so it's actually necessary that we do the load history deflections. One of the things that you might want to add here is that the reinforcement which has been designed by the program is actually, once it is get considered into the load history deflections, the encouraged lengths and the development lengths, actually those kind of extra lengths that we provide generally in our designs is not being considered in the load history deflections, but there is a way to do it. The way is very easier. You perform a design by the program and change all those program reinforcement to user reinforcements. So once you change those to user reinforcements, actually you're considering all full length of the rebars that has been designed by the program, including the anchorages and the development lengths, which probably help in reducing the crack width and also the effects due to the sustained loading. So if you want more accurate results, I would recommend that you will change the program reinforcements to user reinforcements and then do this analysis. Now let's look at this in action as well, that how we can perform the load history deflection analysis. So we'll go to criteria again, and in the criteria, let's say we'll go to load history. And here, the initial load application days and the cure duration I'm selecting here, and the age coefficient. Please know that there is actually no model incompatible with the Indian design code. So I'm using the Euro design code, and the key factor synchronization I put in there. Once you have done that, go to criteria and then to the load history. Here you can see there are 3 load steps. One of them is short-term load, which is at the 30-day criteria, and the load combination which it's considering. And then there is sustained load at 5,000 days. Approximately Eurocode tells you to do that by 3 years time. But you can add more steps if you require. After you have done that, you can directly go to process and then click on calculate load history deflections. Once it has been calculated, you will be able to see those plans. Also, you can get them in tables. So these are the deflections that we are getting for the short-term load, and then these are the sustained load at 5,000 days, and we can see some big numbers here. So I might need to go back and look in those. And then again, the final instantaneous load that we can review these ones. The final topic that I want to cover today is vibration analysis. So the slabs are actually susceptible to vibrations, especially the footfall analysis that we want to perform, that how the vibration get induced into the slab because of because of a pedestrian there or a corridor there, and then the people are walking, and that actually produces or induces vibrations into the floor. Now for that, again, I will go back to the criteria tab. Now in the criteria, let's again click on calculation options. Here in the vibrations, I will select number of modes that I want to consider. The dynamic concrete modulus factor, that means how much the concrete elastic modulus will increase in dynamic loads. So that's about 20% I'm considering here. And I'm performing footfall analysis by the data. I'm considering minimum footstep frequency as 1.5, and the maximum as 2.5 with the damping ratio as 3%. Now the response type is 2, which is resonant and impulsive. So resonant is where the natural frequency of the floor and the footfall actually matches, and that actually becomes resonance. The other one is impulsive, where there is no resonance, but because of a single footstep, there's an impulsive load on the floor. We can excite all the nodes and select the degree of freedom. Once you have done that, there is an additional plan where you can give mass loading. Though all the dead load that you have provided is already considered in the mass, but in case there are extra masses, then you may draw them here. Then let's calculate the vibration analysis. And once you have done that, you can see the velocity, the RMS velocity plans. So these are giving you the response because of the impulsive analysis. And then there is an acceleration plan. But in case you want to see the total effect, that can be interpreted by the response factor plan. And I can see there is an area which is giving me very high value. The value of 1 is what is susceptible by the humans, and 2 is something is recommended for the residential buildings, 3 for, you can say, for work, and 4 for industrial activity. So of course that area looks very not okay. So I may need to go back and review, but all of the other area is under, I would say, 3 or close to 3. Now here is the table where we have calculated the modes, the mode shapes, and the modal masses, and the modal mass fractions. You can also view or export this to external tables, and also you can view the animation of the eigen or the mode that modal analysis that we have performed here. So here is a simple animation of one of the mode. And with that, I'll just tell you one of the other capability of the program is that it can design mat slabs, mat foundations, because there is a built-in tool for designing the or considering the zero tension area springs to model the soil. So the program can do mat foundations as well for you. This topic was out of the scope of today, so I did not consider that as an example, but just for your knowledge, this can also be done with RAM concept. Now, what I covered today is merely an introduction or the capability introduction, but if you want to learn more and want some hands-on experience, I invite you to a workshop on 3rd of December this year itself, and that will actually cover up the in-depth of all the processes that I discussed today. And it will be a full-blown 2.5 hours to 3 hours workshop where we'll give you the data set and the licenses as well for your practice. So I expect you be there. And I thank you so much for your attendance, and please be connected with us using communities. You can go to YouTube channels, and there is a number here through which you can call us and get the technical support. Now let's cover up a few poll questions before I begin the Q&A session today. So just a simple question for you. How many previous sessions of this SIG series have you attended? Because this SIG series has been going on since July this year, and we have covered almost all the products under structural Worksuite. So please record your answer. That will again help us to bring back such series in future. There's one more question for you. Which software are you using for foundation design? Because the next session after this is on foundation design. So it's again helpful for us. So if you can answer that. Please record your answer. There's one question for you that following today's presentation, would you like to be contacted by sales representative from Bentley Systems? So if you're looking for some more, or probably for technical queries, or for you want to know more about the program, you can select yes here. So please again record your answer. And just last one, which is, are you interested in joining free RAM concept workshop that I just announced on 3rd of December? So if you're interested, please type your answer. That will again help us in, with the logistics, of course, if we know already that you're interested. Please know in workshops, we do provide the training license and as well as the dataset to practice. And we require you to practice with us, but not just listen. That's what is expected in the workshops. So please, I expect all of you to be there to learn more about the program. Now let's jump on to some of the questions that we got. Okay. There is a question that does Indian code allows band intendants in both the directions? To answer that question, yeah, actually you're right. That is something is not allowed, but I taken that independence on the inclined portion to satisfy the requirements. So I think that's the answer to your question. Okay, there is one question, how it transfers seismic moments from frame analysis back to flat slab. So that's not back to, that's one way actually. So from RAM structural system, actually it is possible that it transfers at the slab column junctions. At those points, it actually transfers the seismic moments and the shears. So that happens with the integration of RAM structural system and RAM concept. Yeah, there is another question from so the question is, do we consider shorting loads and deflection? Don't we consider shorting loads and deflection criteria? Yes, we do consider that, but the demonstration was just a simple way to tell you that how to perform such analysis within the program. As I said, the more detailed, talk on these subjects can be done with, of course, with more time. And if I select just one topic to discuss, I was constrained by the time and the topic. So, yeah, we do consider that. There is a question how to get this video. This video actually gets uploaded within 1 day as an on-demand. So it will be available to you using the same link that with which you joined this webinar. Please join or you can attend those on-demand videos. Okay, there is a question that can we import RAM structural system to STAAD Foundation? I would ask a reverse question, but why you want to do that? Because RAM structural system in itself has RAM foundation module, which is very robust, and as well the RAM concept. So so whatever the requirements that you might have, whether it is isolated, combined, or the flat slab, the MET foundations, all can be fulfilled within the environment of RAM structural system and RAM concept. Practically, yes, it is possible with the help of ISM, but I would say that it's something to try out before I can put my coin on. Okay, software download link. Yes, we can provide. The link we can provide, and I hope that you can come on 3rd of December, so that we'll definitely provide the link and the training software for a few days, so you can practice with it. There's a question that can we design in client slab? I would say that the answer to that is a direct answer to that is a no. You cannot, but there are ways. A similar question has been asked by many engineers, and a wiki is available on the Bentley communities that how we can consider the inclined slabs in RAM concept. So please watch that. Okay, a question is live load reduction is considered for this. Yes, we can consider, and for this case, yes, we were considering the live load reduction. Once we use the software in the design strip section, there is a tab for live load reduction. So you might want to go there and give the criteria, and it will consider the live load reduction. Can we do soil structure interaction using RAM concept? I would say that with the help of, again, the well-known integrator, the ISM, integrated structural modeling, it is actually possible. But if you are looking for post-tension MET slab or MET foundation to be integrated with a soil model, that would be difficult. But we have done few webinars on how you can integrate a superstructure from STAAD to Plexus. Plexus is our geotechnical software. So yes, that's something is possible, and it's been improving with more requests coming in. So definitely that is something is on our cards. But a simple slab, that will be that means a simple MET foundation, that will be okay. But a post-tension one is something it will be difficult. Okay, there is one question. When we get RAM during the workshop, it is ours to retain, or there are procedures for us to get them to retain for our future use. Uh, I would say that these are all commercial softwares available for use, but of course you have to subscribe for them before you use. For training purpose, we will give you a license for a few days so that you can practice and get hold onto the program after the workshop, and then if you like, please subscribe for it. Okay, there is a question that I want to learn the use of RAM, STAAD, both, because we have purchased SEL. Is there any video available? Of course, it's been asked many times, and there are very good courses. These are courses available, uploaded by us only on learn.bentley.com. Please go to learn.bentley.com and you can find all the courses available for all the softwares that you probably purchase with us. And of course, the courses are free for all the select subscribers. So in case you have SEL, then you are definitely a select subscriber. So for you, you can just directly go to learn.bentley.com and there you will find all the courses. Yeah, definitely. We will provide as early as we can the software download link so that those can be installed before the training. So yeah, we understand that limitation. I'll make sure that we'll do that as soon as possible. So that's interesting to know that you are willing to and want to attend the workshop on RAM concept. Okay, what is the full form of RAM? So there is no full form of RAM actually. The RAM word actually comes from RAM International. So there was a company started back in 1990, and it has grown in US areas and Europe areas a lot with the help of products such as RAM structural system, RAM concept, RAM elements, RAM connection. So in 2005, Bentley acquired it, and since then it is part of Bentley, but the terminology is still going on. So that's I think your answer. Okay, what is the accuracy of this RAM concept? I personally can say that it's my favorite software out of the all. One of my favorites, as in personally, because of its, I would say, accuracy. It's the way it presents the reports. I can know anything in the program, what's going on the back end, and can get a result for it, can get a calculation for it. So that's what I like about this program a lot. And I myself have designed a lot of projects. I've done a lot of projects with it. So it's very versatile, and I think you will love to use it. So please try it out, and I think we'll be back soon on 3rd of December with you on a workshop, and we will send you invites. Whosoever has replied to the poll question, please reply to poll question for us to get an easy way to reach out to you. So please reply to this poll question, which is still on your screen. Are you interested in joining the RAM concept workshop? And we will get back to you. Okay, there is one question: how long the Asian countries are using RAM concept, and how are the opportunities? In India, we have a lot of users. For the confidentiality purposes, I cannot name them, but there are a lot of users here. In Australia, it's a very popular software, um, and it is gaining some insights, and that means some popularity in China. That's why we are considering to apply Chinese design code as well. So uh, that's probably the answer of your question. Yeah, that's there is a question that can we receive any limited version of RAM concept so that we can practice and then subscribe. Definitely, that's what we look for, that in a consumption economic like this, that people wish to try uh, the software before they subscribe for it. So definitely please come in 3rd December workshop. We will provide you a few days license so that you can practice, and then if you like, please subscribe it. And I wrap up this session now. I think I almost covered all the questions, but if something remains and need more, or those questions require more investigation, and then I will definitely reach out to you through emails. So stay tuned with us. The next few sessions are going to be very, very interesting. So I hope you I hope you will be there and attend them. And thank you so much. Bye bye.